Why do I forget this? No, it's not what I meant. Yeah, the requires, that's what I meant. They can just add a requires. That should work. So I don't want ever to create a multiplication where the second argument is a constant. That, so this just makes sure that that never happens. Hopefully it still compiles. Parentheses required. So I still don't know the syntax then. Oh, just like that. Template requires parentheses type traits. No, I already never did that. Yeah, well, here I have 1 times x, etc., but 1 is up front. Now, if I would have the 1 anywhere else, I don't think that that would even be possible then. I think it already resolves it. Say I try to, well, I don't know, simply print. Of course this works, constant. No, it's just up front. Yeah, this needs parentheses as well. See, now I'm not convinced. I mean, this works, but yeah, now the constant was up front. I'm suddenly not sure anymore what happens if I put const, say, at the second place. No, it does compile. Yeah, just puts it at the... No, of course, no, no, never mind. That's resolved in the operator star. The operator star is defined for a symbol and constant, and then it switches them. But if I do x times constant, now we get a problem, I think. I'm not sure. I mean, I defined operator star for symbol times constant. I'm not sure in this case. This is a multiplication, and then does that swap as well? Probably. Actually, yeah, maybe. Oh, it's this. Yeah, okay. Still puts it up front. I did not update that one, but it is really at the second place. And then why not? Let's test putting it at the end. Because I don't have to think. Just test everything. No, and even then it moves up front. And then of course I want to combine constants. So now what happens if we do, let's say, well, second constant. Constant 1 times a y in there. X constant 2. Then both constants want to go to the front, and then they should be combined. I think that even that is working already. To be honest. No, it's not working. I have two constants. Maybe we should turn on parentheses always, so I can see how many, well, which multiplication is done first here. So just return true here. Always need a parenthesis for the multiplication. So we end up with 13, let's put up front, yes, and then times, and then the 42 is up front again. Yeah, we first do this multiplication, and then that multiplication, and then that multiplication, and then that multiplication, and by that time we don't know anymore that we're multiplying 13 to 42. How to fix that? Hey, Said. No, I don't know. Maybe the code, but I'm sure you know how to multiply. There's not even addition here, it's just simply multiplying. So multiplication is now the difficult word, I can't even remember. Commutative. So the order doesn't matter. But since I want to combine the 13 and the 42 in the result, it's nice if they are like immediately next to each other, which is not the case here ish, because of the parentheses that are hidden inside. It's the order that it calculates them is first this and then that and so on. It's probably a good thing to order them anyway. Say, put all the x's together. Well, that's just x to the power 3. You'll probably want to know that. I probably even want to replace this whole list of multiplications with some other class that represents a symbol to some power. An exponentiation. So we have to collect the same symbols. List of products. Constants first, and then the symbols. Grouping the symbols. That means that every multiplication must be ordered. But. I guess this should become 42 times parenthesis open x times y parenthesis close. Does that make sense? Isolating the constants. Hey, owl. Const. Multiplication, just symbols. It's at some point there is something that is not a symbol and not a const. Say one of these things is a sinus of x. I don't have a sinus yet, but or an addition, anything that's not a symbol. Then I want to do what with that? Well, you have something called expand. You want to multiply it out maybe. So there's always a limit to how easy it is to simplify stuff. At some point you have to stop, I guess. Definitely not now. So, yeah, I think I have to concentrate on the simplest of things first. And having only constants and symbols in the multiplication. Then how would I be able to manifest some ordering in that? Let's think about that. Oh. So we could rewrite this as a that. Which in itself isn't that easy. And now I have again. Okay, so if I have a rule like this, so that is a constant times something, and that whole thing times something, then I want to swap the order of the multiplication. So in that case, I'm going to first multiply those two and then the constant. Then once that rule is implemented, it's going to do the same thing again here. It says, oh, wait a minute, this is a constant times something and then times something. So I want to swap that multiplication as well. And then it will do that again. So now it says, oh, this is, etc. 42. Like that. And now I can also detect maybe then the 13 times 42. And I guess the reasoning there is that it's not necessarily the constant, it's more like the, well, let's say, alphabetic ordering where const comes before the A. So here you have something like y is larger than x in lexicographical order. So this is larger than that, therefore we swap the multiplication order, which is actually the same thing I already did for the constant. And the same here actually. The order must be in that way. Now why would I put the x up front? Because it's a single symbol? No, that's not correct. Let's see what I want to end up with 13 times 42 times x times x times x times y. I want to combine these two. And this one, yeah, I don't really care which one I could do first, but let's group them. And then maybe those first. And then I guess those. This looks like a nice ordering. So for example, if this one is already correct here, so I swap these two. Then I want to group the cons here with that one instead of with that one. So you can see this as a multiplication of A and B. Sorry, A with a multiplication of B and C. And that has to go to multiplication of A and B. And then a multiplication of with C. Why? Well, in this case, because A and B are constants. I want to group constants together for obvious reasons. Can implement it separately, but I have a feeling that if I just treat the constant and symbols the same way and give them an overall ordering where constants come up front, that this should happen anyway. Meaning that, say, if we have something like this, but A and B are not constants, let's say A is a constant, B is X, and C is Y. Is that different? Can make here also Y. I'm not sure that this is better now. No, it's not better. I do want to have the A completely separated. Yeah. So I only want to do this if B is also a constant. Okay, let's implement that. Let's implement that one at least. Push constants out. Let's just choose X as arbitrary thing. It's not really a symbol even, it's just some expression. Okay, I'm gonna use it in A in E for expression. Arbitrary expression. Then we have the possibilities, all the possibilities, probably a lot, are multiply on the right or the multiply on the left. So already this basically. And then all the possible orders. So let's swap these two. And then I get B Yeah, well, that doesn't matter. So you just swap A and B, they're both constants. But for now, let me do all of them. So this is an E and A. And then, of course, we have E here. And A and B here. Or B and A. It's kind of ridiculous, but... And then all of them again. And I swap this whole thing. Swap those two. So now we have every possible combination with an expression and two constants. But I don't have to think about the difference where A and B are swapped. So we have this, then BAE is not interesting. And here BEA is also not interesting. And this is not interesting. Yeah, we have, well, let's remove everything where B is up front. Simple. Oops, not that one, this one. So yes, we have AB, 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 and AB, AB, AB. And then do... Let's move E from right to left. And then think about it. So in this case, I want to get a multiplication of A and B together, which then automatically combines the constants. So this becomes, I'll call it C, CE. Okay, now the second thing is my multiplication can't even exist if the second argument is a constant. So this will never happen. Might as well delete it. This can't be a constant. What would happen if you try to make this multiplication is that you get BE already, which you already have here. So it does not exist. This one does not exist because this would be C. And then that would be reordered as CE. So you would already get that one as well. This one is also, this would be a C. Which is also already that one. And this is not allowed. That would be, the B would be moved up front to begin with. So it can't exist. And then we said, well, swapping A and B is not very interesting. So, oops. Redo. So this is actually equivalent to that one, and then we get this one is the same as that one, and this one is also not allowed. That becomes also that one. So this is really the only special case. Automatically taking care of everything constant. Currently I'm having anything and then special cases for multiplying with 0 from left to right. Multiplying two constants, that would produce the C from the A and the B. Multiplying constant with a negation and negation with a constant. And multiplying two negations. So now let's add a specialization for this. I guess we now have 3 auto diffs. Auto diff is just a concept that disallows things that are not part of this library. Otherwise, it would be a bit annoying if it catches ordinary multiplication. So I have a T3 here. I don't know what the return type is yet. So now we have a multiplication of a constant. Let me copy that. Here's a constant. Argument 1, and then a multiplication between the other two. But this is also a constant. So again a constant. And then there is no T. Well, it's just one T. Oops. Rip. Did I still call it T1? Could call it T3, yeah. It's the expression here. I don't know how to call it. T3. I think this catches it, right? So if you try to multiply a constant with a multiplication that starts with a constant, then you have this case. And then we want to return a multiplication. That's this M here. I can do it, I can even skip this step maybe. Otherwise it would just, I can create a multiplication of 2 constants. Yeah, why not? But then it will call the other one. But I'm not going to duplicate it. So let's just return a multiplication of a multiplication. Let's see how to do that. So basically I would just want to arg1 times b, where b is the first argument of the second thing here, comma, and then the e, which is the second argument of my multiplication. No, looks good. If it compiles, then it is good. You already had that. Now what did we have before? What did I have before? I had the same thing here, so this doesn't test anything. Let's add my own parenthesis to test it. Test the simple version. I want to test, let's say, y times x times constant. Doesn't get any simpler than that. So yeah, this immediately swaps them, and then you get that, and now my trick doesn't work, because this should have been changed with what I just added. Why is it not doing that? Ain't that really weird? Yeah, we don't even get there. Then where do we get? It really confuses me, this whole specialization stuff. Is it not a specialization? It should be a specialization. Constant. Let's see, I have I would think it's a specialization of this one. Well, let's use entering. I don't have the arcs here. I'll add them then. Although maybe it's not even necessary to add them for the zeros. That were all the operator stars. But now I'm printing arc1 and arc2. This one is called multiplication. Is it debug only or CW debug only? I think CW debug only. Oh, I missed one. Actually missed two. Hey, chemical gems. Well, maybe you can help me then. Some hints. Okay, here we are. So it does enter x times 42, and then y times that, and then it doesn't do anything. Now I think though this operator is just the most general one, so this special case is not taken. Why? So this being the most general one. Huh? I'm gonna ask the Gemini. I don't know why this so I don't know. Maybe it has a maybe it says something that is useful. Start a new chat. C++ 20. I won't confuse it with the debug output because that's macros that it doesn't know. And the auto diff is, yeah, maybe I should tell what auto diff is. No, that doesn't restrict anything, so I might make it a type name. I don't think it makes a difference. Yeah, so I'm already using tags and concepts, and I thought that this would work, but apparently it's only the first paragraph here. It says that it is not possible. Template specializations cannot directly specialize generic function templates. Function template specializations are designed to provide more, I don't know. Can you elaborate on function template specialization? You are correct in thinking. I'm not correct in thinking. I repeat what it said. But you cannot directly specialize a function template. Yeah, you already said that. By providing a more specific set of template parameters. A function template acts as a blueprint. Hey, Devon. For generating functions. Attempting specialization would require modifying the template itself, not just the generated instance. I still don't get it. Why the difference? The reason for the distinction lies in how C++ handles code generation and compilation. Function templates, the compiler generates a concrete function implementation only when it's used with a specific set of template arguments. Direct specialization would mean altering that generation process on a case-by-case basis, reducing complexity. Class templates, compilers equipped to create tailored class definitions based on the provided template arguments. The structure of a class is fundamentally altered through specialization. Well, okay, I'm like, but I'm gonna assume that it is not possible. So I have to do either tag or more concepts. Or if cons expression, maybe the latter. Let's just do the latter. Zip. No, there was an attempt, but I do have a specialization for this. It just picks it up. So don't ask me why that works. Well, maybe asked. Fuck, I should ask a human. The downside of streaming. I feel like I cannot go to IRC and see if I can find a guru who knows this. Because that might take a long time. No, this is again horrible. Now I have to ask for if it is a template, if it is a multiplication for an arbitrary T3. Which is way too difficult. So maybe it is possible probably, but I might as well use another concept then. Let's see if we can overload this thing for constant, at least for the first argument. It's also possible that it just doesn't work because I'm not using auto here as a return time. Now I think about it. Let's try that. I'm gonna go all the way back. Uh-oh. Yeah, this one is auto, this one uses multiplication. So I think the other overloads do work. Yeah, these return 0. That's all completely different. I have no clue. Let's begin with asking Gemini why it thinks that this works. Well, here I actually do use a concept. Okay, let's use this one. Let's use this one. Okay, it's just preferring it because it matches and it isn't even a template. But it's not a specialization. Let's move this one closer to the thing that I'm trying to overrule. Instead of scrolling up and down. This one. Yeah, I would say this is also overload because I'm specifying constant directly here. but it is a template. So apparently it doesn't really care about the first argument being an exact match when it is a template anyway. Right, well then what we can do is stop this one from taking a constant as first argument, and then so I have a concept already for that, so accept constant. No, sorry, I don't have to accept constant. Let's just do it here. Requires standard is same. Well, actually not. So T1 is not allowed to be a constant. Well, and now of course it's going to use this one, but then everything fails where this one had a constant. So now here I have to accept both. No, I have to accept anything. I mean, let's call that 2. A second argument, so we just accept any argument again. And I wanted to do my if const expression again. How the fuck did I call that? Derived from template. Derived from template can do only template with a single. No, it can do lots. It can do any argument. I think it can do any argument, but it cannot specify an argument. Let's try this anyway then. So I can do if const expression utils derived from template v, and that takes derived first, then the template. So T2 is a multiplication. Then we get here else, well, the default is just doing the same thing. So yeah, now I disallow a constant for T1, and then if it is a constant, then we get here. And then if the second argument is not a multiplication, then we do the same thing as there. If it is a multiplication, then I still have to check that the first argument of that multiplication is a constant. So now I can do if const expression blah 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 is a constant. Then we do this. Now the problem here is that since this is auto, it has to derive the return type from the return. Now this only happens when T2 is a multiplication of a constant with something. I still have to write this, but this happens always because it's not part of the const expression. So then we have two different return types. I probably won't compile. So I'm doing else. And then we should get either this one or that one. However, if now this const expression is true and that one isn't, then it doesn't work. So I have to combine these then. No, I can't. This test is only going to work when it is already a multiplication. So we have to do here another else with also that return type. So now I can write this test knowing that it is a multiplication. I just have to extract the first type from it. So that would be T2 and then let's say argument 1 type. And that is then a type that depends on a template parameter, so I have to put type name in front of it. And it must be equal to constant. So standard is same v. Wait, I never know which I put first. Constant is second here. Well, so let's do that again. Job. So if T2 is a multiplication and then T2 has the argument 1 type, it should have it. And if that then is equal to constant, then we get there. I think this should work, except of course that I still have to add that. Multiplication, let's make that just public using T1, and then why will I add it? Argument 2 type is T2. No, we have to wait through the compile errors and fix them. Oh, there's no multiplication anymore. This is now arg2. Zip, 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 zip. Use of undeclared ID again. Error, cannot deduce return type. Yeah, because I'm using an auto, I obviously have to use auto now because the return type depends on the const expression is. I have to specify here that it is a multiplication. Use of overloaded operator star is ambiguous. Operator times constant and 0. Ah, okay. Now it doesn't know what to use if you do constant times 0 because I added something that begins with 0 and then suddenly the preference is the same. What is it? How do you call it? So I want to exclude 0 from that new addition. And the new addition is... Yeah, this is explicit 0. So this is my new addition. We don't want to allow... Come on, accept 0. I have that as a concept, so that works. And then it compiles, and I will see what happens. Hello, where is it? There. Doing. And nothing happened. Oh, you got to... Really? No! It's still the same. Also printing this, so the we get here is not... How is that possible? Okay, now we're gonna... Teflon. I'm not even sure if you're being sarcastic here. 268 hours? Who did that? I was here, but... Well, some people were here, yeah. Abhimanyu was here probably all the time. Hey Ninja, I didn't see you there. Make... Yeah, we're going to be really fancy now because I want to know what's going on. We do that by printing the actual types. So we get here and I want to know what the type of T2 is so that they understand if we get in here or not. I mean, we can start with that. We get here 1, we get here 2. Actually, maybe I might not recognize that one, so we get here 3. Maybe it still doesn't work for const. Well, that would be really annoying. No, definitely should get there. Good job. Oh, yeah, I do. Differentiate. No, we don't. So we don't. We don't get there. This is the code that I'm testing. We still do not even get there. That's impossible. What the heck? We're talking about this multiplication, right? Which would be this one. Oh, y is not a constant. Huh? Oh, wait a minute. Yeah, y is not a constant. I'm testing the wrong thing. Oh no, really? How long have I been being misled? Misleading myself. Oh, that's really bad. Yeah, okay. Constant. Let's test this. Because that's what I have been working on for some reason. But that would explain why I never took that other function. So maybe it did work. Oh, how stupid is that? Now we get there. 3, 1, 2. Yep. So now it does combine the two constants. Yay. And I'm stubborn. Now I want to know if this really didn't work and all of this is necessary. It's not that much work. I just copy back from Gemini. So that's really stupid. The reason I didn't use this function is simply because I wasn't passing a const as first argument. Ugh. What a waste of time. Valid operands, the binary expression, constant and differentiable symbol. I think I know what I did. Again, extremely stupid, but... yeah. Well, I thought I commented this one out as well, but it's almost the same. Disallowing a constant, so I have to re-allow that. So it does work. Yeah, Gemini is full of shit. it does work. No, okay. So, well, what we learned something, right? Right. Yeah, I'm gonna go for the easier version then, not with all those const expressions. Yeah. Let me think. What can we test now? I think something went wrong there. Very wrong. We lost the y. We lost y and we lost the constant. Or I did the same thing as I always do. Yeah, that's what I did indeed. I update the comment, I update the output and then not the actual thing. Yeah, which brings us to a multiplication that starts with a constant times a multiplication that starts with a constant. Totally true. So now I have support for constant times a multiplication that starts with a constant, but not this, two multiplications that both start with a constant. Let's see if we can add those. So that would be a multiplication, start with a constant, and then some expression. Well, expression 1, expression 2. Just extract the constants and combine them. And, well, that would be something like this, but not quite. Where now we have another type name. I don't know why I call 3 there. Probably because that was the third. So now we have 1, 2, 3, 4. 3 and 4. Why not? 2 and 4. And then this ain't a constant, but it is a multiplication. Another multiplication. Damn it, just call it arg. Let's call it arg anyway. Multiplication times a multiplication that both start with a const. And then we do yeah. Thank you. Multiplication I guess now we have arg1. That is the first constant times arg2 arg1, second constant. And then arg1, arg2. Poor compile. Don't see anything. Did not combine it with the other one. Now what? This is a multiplication with a constant times not a constant. And this is always not a constant, so I don't care what that is. And there's apparently also a special case. We have to keep adding special cases like there's no tomorrow, isn't it? Oops, copied it back from Gemini, but I changed that into type dev. Auto div. Type name, I mean. I don't know, something. Auto operator star. That is a multiplication with a constant. And then a T2 times T3 arc2. And now we return a multiplication of the constant times another multiplication. The constant being the first argument of the first multiplication. And then this is the second one, so arc1 dot arc2 times arc2. What is the problem here? Oh yeah, ambiguous, so I have to suppress something again. The thing that I added was this one. Yeah, probably have to suppress const for the T3. Not even sure, but maybe it's time I add that. Because 0 is also a constant. No, it's just, I don't know. Well, if it barfs on this one, maybe it's also going to barf on the 0 then. I still don't add it. Requires. Oh, what? No, I do need this one. But now here we have, I lost where I came from. Undo, 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 undo. There's no undo. Okay, just write it, open it again. I think that was it. Equals and T3 is not a constant. Stupid thing. Well, I got rid of one parenthesis, but still not combining it, which is pretty weird. This looks like a constant times a multiplication that starts with the constant. I thought I fixed that. The last one is this one. So we have a constant times something, comma, constant, and then it swaps it. And apparently that then doesn't trigger whatever. And the reason it doesn't trigger that is because I'm not using a multiplication. I'm just constructing the multiplication. Sorry, yeah, I'm not using a star. I'm constructing a multiplication directly in that case. So this is a multiplication of something, comma, constant. I get this one. Yeah, and then just swap them. But now we have all kinds of special cases for T1, so I probably should not do this, but simply use a star again for any additional multiplications. And now it did work. Combined all the three constants. Awesome. Now what's next? You see what a lot of stuff it is doing. The first thing it tries is, well, first it multiplies x with y. That's this one. Then it multiplies that with 13 and then puts that 13 up front. Now I'm using a star for that as well, so it turns that into this. Then it multiplies x with x. Then that with a constant. Again, putting the constant up first. Then multiplying those two things. And then these two multiplications both starting with the constant, so then it combines the constants. Then it combines the rest and then the whole thing. Oops, this is the whole thing. And then that is multiplied with y. So I guess now we have all of that, and then times the y. Yeah, and then it peels off the constant again. So we just get a multiplication with this part without constant. And the result of that is then multiplied with this constant. And then finally it's multiplied with constant 1. Which then is put at the first place again. Which then causes this constant to be peeled off and multiplied with the first constant. Which is this one. And then the rest. Funny. Why do I have a feeling that... Oh yeah, right. Because the debug output, it cannot be const expression functions. If I made it const expression functions, then of course it would be really all done during compile time. And that makes you wonder, can I make it const expression functions? So this is really all done during compile time instead of runtime. Yeah. I'll test it after I am done with the debug output. Now I have to do something like this, but then for the symbols, single symbols. I guess it is like literally the same thing. Meaning, for example, if x was a const, at least the first x was a const. Or maybe I should treat them indeed as an exponential. Maybe I should first introduce exponentials. So then we get an x to the power 1 times an x to the power 2. And then it would still see that this is basically then treated as a constant. Then we would have a constant times a symbol times a constant. Then the constant would be put up front. So then you get x squared times x times y. And then it sees that the x and the x squared have the same base. So then you get x squared times x, all times y. And then we can combine the x squared times the x. So then again, get x to the power 3 times y. And then again times y. And then you should get something the same. So in the end, then this is going to be x to the power 3 times y squared. And I might as well use exponentiation for symbols from the get-go instead of completely sticking to multiplications. Doesn't really make sense, I guess. Yeah, so new class required exponentiation. Already have division, but not testing that yet. In a minute. Differentiation. I didn't do differentiation for. Oh, differentiation just starts here. Yeah, no, let's move that up. This is differentiation of 0, so I should move that to 0. Well, to the top. 0 is defined in the header. This is differentiation of anything that is not implemented yet. You can move that to the top as well, because that's actually my template that must be overloaded. Yeah, it should never be reached. I'm going to use AI never reached. It's kind of silly to return 0. Now, it's not going to know what this is, so I might as well make it a void. I think that works. Differentiation of a negation. Yeah, it's not consistent. So I have evaluate before the operators, and I just saw a different order. Evaluate. Or not. So static assert works using a dependent on t here. We'll see, I suppose. So this is the evaluation of a constant. Which comes below the 0, okay. And this is the evaluation of a symbol. This is evaluation of a 0. I thought I already had that one. Nice, differentiation. So first concepts, first the class, then concepts, then evaluation, I think. I mean, you got to stick to some order, right? And then the operators, and then the differentiation. Then addition, first evaluation, then operators, differentiation, subtraction, evaluation, operators, differentiation. Loads and loads of operators. No, I didn't see if it started with evaluation, but I guess it did. Yep. Why? Now we get to division. Evaluation, operators, differentiation. I don't think I have differentiation yet for division. This is differentiation of a constant and of a symbol. So those two need to go to the top. Right. Yeah, so that this is not working. Oh, wait a minute. I put the wrong thing. Zip. Okay then, exponentiation. There's no this. You can't see. What you see is nothing to do with the distribution. I am using Arch, but if you like my colors, then this is a completely different thing. It's just custom. Exponentiation is probably should be also yeah, I think just one template parameter. That would be the symbol. No, so it's nonsense. I just want a symbol. That is, maybe I want more than a symbol, right? I just want to have some kind of expression to a power. Yeah, unfortunately. I don't think I want to support having exponentiation to the power of something that is not a constant. But it could be an arbitrary expression. To maybe not zero. And I'm wondering if I'm doing it to a constant. I should have a half, 3/2. Not really have a need for exponentiation to some double, I think. Maybe to a rational number. So could do two constants. The numerator and denominator of the exponent. Now my constants are actually doubles, so yeah, and I'm not really constants, right? I'm just going to do internal, I think. Could write a complete library for rational numbers alone. I don't feel like doing that. Let's start with just integer exponents. Okay, let's just do constructed. Why not? Accessors need parents and everything else. I'm just going to copy it because I can't remember all of that. Very lazy. Copy everything. De constructeur. Hè? Yeah, both 0 and 1 should not be allowed to begin with. Let's not have a default. In fact, let's assert that we are never ever use an exponent. Equal to 0, 1. That would be stupid. Now, when does an exponent need a parenthesis? How do you pronounce that? Parenthesis? Never, I think. And everything else, everything that I have now is, I don't know, just add a new thingy before and after exponentiation. There's no arc2. It's not before or after, it's just when it is exponentiated. How did that work again? Or just like that? Nah. I don't know. It's been a year since I used that. Anyway, I want the superscript. Minus, hello? Superscripts do not have minuses. Well, we have a plus. Oh, this is the minus. It looked like an underscore. I think this makes it a string of char8 type or something like that, which is probably not what I want. Might not even compile. Let's try that out. Invalid suffix. Nobody gets this. String literal. 8 goes in front, okay. Okay. If you say so. Yeah, it even gets a color now. I could have known. Does it compile now? Well, we don't have an exponentiated yet. Yeah. Got to look all at the parents. If it is exponentiated. So if an addition is exponentiated, then it does need parents. So yeah. I should look at the needs parents, I guess. Subtraction, same thing, and indeed that is true. And this is temporarily true, but also it is equal when it is after diff. but then also if it is exponentiated. Division, same thing. Everyone needs it. Oh. Overload resolution selected, deleted operator. Well, I had the feeling that this would not compile. Let's just use that. And now it compiles, okay. Fine. Now, then I have to define the evaluation of my exponentiation. How do we do that? I just copy something randomly. Oh, it's yeah, okay, so yeah. And then we go down here and paste it and fix it because we have only one thingy. Evaluate exponentiation. Having a single argument. I'm going to assume that standard power works exactly for integer exponents. Or good enough anyway. Those doubles are an approximation anyway. So what do we get after this? I could do an operator. No, why not? Let's use the operator thingy, this, as an exponentiation. Oh, I didn't finish this one. So if it is less than, we print a minus sign. And actually I have to print that thingy in. No, I was going to use subscripts. Switch or OS. Digit. Actually superscript. exponent is never 0. So we can do while exponent is so 1, 2, 3, 4, 5, 6, 7, 8, 9. Except that it has to be a string because it's a multi-character UTF-8 thing. Substitute that with that. Yeah, the way I want to go through the trouble of supporting exponents larger than 10, larger than 9, meh. I guess so. It's not the mod, let's call it a diff. I need the second E. No, actually I want to start at 1 then, so I can divide by div. So I'm going to divide by 1. If E2 is larger than equal 10 times div, then I guess maybe I should divide div afterwards by 10. So normally we divide by 1. This never happening because E2 is less than 10. And then divide by 1. So I just print a digit of E. And let's say it's 13, then 13 is larger than 10, therefore divided by 10 is 1, this becomes 10. Is now 1 larger than 10 times 10 times 10? Yeah, 100. But I already divided it by 10, so that is no. That looks better, isn't it? Yeah. Just count the power of 10. So we do this once, now div is 10, and therefore this print a 1 first, and then this becomes a 3, and this becomes 1 now. So it's still larger than that, so we print a 3. And then this is a 0, I guess. Div is now 1, so and that becomes 0, and then we get out of it, and then printed a 1 and a 3. What comes after evaluation? Oh yeah, what's an operator? So I'm going to have an operator this for something or int exponent. It is then template. Auto div T1. I think I want to make an exception for zeros and actually also constants probably. But you can. I don't know yet. I'll just see. You see this problematic if exponent is 0, that should just never happen. But it's kind of hard to test unless I make it in a const expression. Function, which is very dubious because, well, the first argument isn't necessarily const expression. I don't know what is going to happen here. Okay, well, anyway, after operators we get the differentiation. Maybe we should add a differentiation of the division as well already. How does it work again? I believe I forgot that. Yeah. I have a vague feeling what it was, but I forgot it. That differentiate the division. The quotient rule. Yeah, that's exactly what I thought it was. No, seriously. Yeah, so I still remembered it, but I wasn't sure. It's kind of the same as multiplication, except you have to divide by that, and this is a minus sign. In other words, differentiate that one by symbol times that one minus this one times the other one, and then all divided by the square of expression 2, which then is an exponentiation, believe it or not. Exponentiation. Move differentiate down, or shall I move exponentiation up? Exponentiation is kind of like special case of multiplication-ish. Well, negative exponentiation is the same as division. Probably have to move this one down to below exponentiation. What? This is the one that should be used. That's line 701. Oh, forget the differentiate by x. Yep, that works. 1 times y. So, yeah, well, the minus sign is gone. That's suspicious, but I guess minus 0 is just evaporated. So the correct solution was the derivative of partial derivative of x, so this is 1, times y, which is this, minus partial derivative of y, which is 0, times x. So yeah, that's why it's not there. And then divided by y squared. So, and I could have seen that immediately, because obviously the partial derivative is 1 divided by y. I still need to kind of special case multiplication with 1 somehow. Get rid of the constants. But that's pretty damn hard. You see that the exponentiation works, and that it at least is being printed. Okay, I'm getting tired, but let's do a differentiation of x to the power of 5 dx, which is clearly not working yet, because I don't have a differentiate for the exponent, but we'll can add that now. Differentiate, I guess I have only one of those. And this is on then an exponentiation. The result is, yeah, that's again dubious. Depends on. Damn it! I really have to start using const expressions. So look into that, of course. The return type would change depending on the exponent. Not only that, it also depends on. Well, I have that one as const expression. Okay. let's first assume that this is indeed the base of the exponent. Then I need an accessor for my exponent, well, which I have, that is exponent -1. And then the whole thing must be multiplied with a constant. Which is constructed from the exponent. Yeah, for an arbitrary expression, this is actually always the case. I'll have to specialize the case where the T1 is a symbol and then check if this symbol is equal to this symbol or not. But let's do this slowly. No, that works. X to the power 5. Derivative by x is 5 times x to the power 4. Yeah. But yeah, it's not true then, right? Let me think. What I really want is to multiply this again with the differentiation of the argument. This is division. Yeah. This whole thing must be multiplied with the differentiation of the argument 1, of course. Common symbol. Yeah, because it's an arbitrary expression. So if you have, say, some function of x and y to the power n, and we take the derivative of that. I don't have partial derivative things here. I assume that is a curly d. Then that is n times f or x comma y to the power n minus 1 times the df too trivial, not even adding it. And then that would take care of, for example, having x to the power n and then differentiating it by y, because then the latter is going to be 0. Okay, now I'm confused what is not a times 1. Oh, the 1 was pushed up front and combined with the 5. So that disappeared. Yay. Should be able to see that though. Yeah, here. So the 1, the x, the derivative of x by x is 1. You can see that appearing here. And then if you do the derivative of y, I can do that. The y to the power of 5, then that should be 0, right? Use of overloaded operator star is ambiguous. It does get an internal 0, which is a good thing. And then it can't decide between actual 0 and something else. So this one must disallow 0 then. Yeah, of course it must disallow 0. So 3 must not be a 0, except a 0. And then we have 0. Totally working. Now what is not working? Let's make it a little bit different. So x plus y to the power of 5. I think this is also working. It's just 4 times x, 5 times x plus y to the power 4. Maybe more exciting, y minus x. So that would minus 5 times y minus x to the power 4. Yep. And then if I do x squared here, then it must become minus 10. And then this, and then times x, if I'm not mistaken. To the power 2. Or we crash. Oh, we got an exponent equal to 0, 1, apparently. Is that true? Yeah, indeed. Yeah, we got an y minus x to the power 24. That's probably a 2 and a 4, but still. Oh, this is, oh, damn, parentheses are missing. So we do need parentheses if it is an exponent. So there must be parentheses. To do the square and then to the power 4. And then of course you must combine the exponents, so this should have been to the power 8. But let's start with adding the parentheses. Exponentiated. Yep, so now it's like that. Can already combine them, why not? So an exponent to an exponentiation exponentiated, right? That's something we want to short circuit. On so if t is an exponentiation already, then I want to get the argument of that, and then we do that to the argument dot exponent times exponent. Why are we not crashing? Oh, it's plus. No. How do we get a 9 here? What is happening? Yeah, I don't think it's correct, right? I mean, it's not correct. So it should have been, let's see, I have y minus x squared all to the power of 5. And then the ddx of that, that's 5 times y minus x squared to the power of 4 times minus 2x, which is minus 10x times y minus x squared to the power of 4. And it should still assert, because that we do get an x to the power 1, which I did not want to allow. But for some reason it combines this into a 9, like 2 times 5 happened. It should not happen. I don't know what happened. Didn't add. Did all debug output. Okay, so we enter. Wait, before I even look at this, let me verify that this is the same as what I print here, right? I minus x squared to the power x, to 5, I mean, yeah. I see, man, no I don't. So, First thing it's doing is, oh, y minus, oh, that's not good. That's not good. Right. I'm using this as exponentiation, but really it's an XOR, so the ordering is not as I expected. The compiler thinks that subtraction goes before the XOR. So it does a y minus x and then to the power 2. Duh. Yeah, then you get to the power 10. Yep. Okay. Problem solved. So I have to explicitly tell it to do this first. The other one should work. So now it works. You have first x squared, then we get y minus x squared to the power 5. And then we want to differentiate that, which is then 5 times this thing to the power 4 multiplied with the differentiation of that. Well, that is 0, and this is 2 times x to the power 1, and that is not allowed. I want to turn that into just x. Yeah, I don't know how to do that. The only way to do that is if everything was const expression. Everything is const expression. Is that even possible? Maybe it's possible, actually. Why not? No. Yes, of course it's possible. The evaluation cannot be. But the whole building of the formula and the differentiation could be const expression. Then you get really compile time differentiation. So I'll let the adventure begin. We're going to just begin with, well, I'm going to commit this to Git, because this is again a crazy change. Maybe this is a good moment to stop. I should go to the shop and buy food. Otherwise, you know, I'm not taking care of myself very well. I think I do that and then cook and eat, and then I'll be back. Yeah, this is just an endless story anyway. We make slowly progress, but it's never really finished. No, well, not today anyway. Const expression. And then, of course, I add a const expression anyway. Exponent. I'm not sure if a temporary is a cons expression. If you make the constructor cons expression, it's an interesting question. Not sure if this is allowed either. But we want to get to the exponent as cons expression. Non-static data member cannot be cons expression. Yeah, well, let's make it constant. But that won't help. I don't think exponent, well, I didn't complain about that, so maybe. But unlikely, right? Unlikely. The problem is with the differentiation if the exponent becomes 0 or 1. So I would like to do if const expression something else return if const expression this is so not going to work, exponent yeah. Yeah, this is just this to the power 2 minus 1. So to the power 1, so this is just this. And I still have to multiply then with the differentiation of that thing. But now it's going to complain that this is not a const expression, I think. Yeah. Even though the exponent is a const expression. This is only going to work if this is a const expression. Why would it be? I think I have to make this a const expression then. And then pass const expressions. Might as well drop the const reference. I'm not even sure if that's necessary, but let's begin with doing that. And then well, it cannot be a const expression if I print debug output, unfortunately. So I have to remove that. And then it's going to complain probably that this is not a const expression, and this constructor is not a const expression, and this differentiate is not a const expression. You get a load of errors. Load of errors. Const expression if condition is not a const expression. Please explain. Yeah, I think that it is the problem here is that in instantiation of, that comes from here. I'm not passing a const expression. To, at the very least, x and y must be const expressions. Well, I can make that. I hope. I hope. Which then means that the constructor of these things must be const expressions. Wait, why am I jumping there? And that's not possible because it's storing something in a static. No, let's see. And then I'm going to do shopping. Okay, let's see. Constant expression variable x must be initialized by a constant expression. Okay. Read of non-constant expression variable as name is not allowed in a constant expression. So at the very least I have to make as name a constant expression. Instead a constant expression is possible. But then, yeah, the assignment is a bit weird. I can't do that here anyway. So now the whole thing is a const expression. Suppose you can initialize it like that. Although I'm not sure. Const expression variable as name must be initialized by a constant expression. Yeah, must be initialized right there. Okay, so that means that this is not working. I probably... Yeah, I did something dirty here anyway. Using statics, assuming that the user would only use a single instantiation per ID bit. The compiler won't have that. That assumption, as it were. I think I need to make these things then also part of the template parameters. So the value then even come, no, I can't have that. Value is not a constant expression. Symbol is not a constant expression. Value is assigned later, so it's just not const. Name is printed by debug output, so there's no reason to make that a const expression. Plus it probably can't be. Therefore this is not a const expression, period. Might as well assign it and test it. No. Yeah. So now this is no longer a cons expression, so I can't make this a cons expression. I mean, I'm assigning a value afterwards, so it's totally not a cons expression. Which brings us back to that I'm doing stuff here with non-cons expressions. I don't know. I'm going to buy food. I'll be back. I said turning off the monitor instead of stopping the stream.